Welcome to this month's edition of Mastertech, Sound System Diagnostics. This release is divided into 3 sections. In Section 1, we'll be looking at the new and available sound systems for 1991. In Section 2, we'll cover the differences between AM and FM broadcasting. Most of your customers may not be aware of these differences or of the natural limitations of both of these forms of broadcasting. This information will be very helpful to you when you have to explain to a customer that the problem is caused by an outside natural phenomenon, things that are common to all radio reception and are not the fault of the radio. In our last section, Section 3, we'll diagnose some sound system problems using the troubleshooting charts in the September Mastertech reference book. There are 8 corporate radios offered for 1991, 4 standard line and 4 premium radios. The 4 standard line radios are the RAL, RAS, RAB, and RAF. All 4 of these radios are carryovers from 1990. The only change made for 1991 was the deletion of the AM stereo from the RAL and RAS radios. The 4 premium radios for 1991 are the RAN, RAY, RAX, and the RBB. The RAN, RAX, and RBB are carryovers from 1990. The RAY radio has a totally new look for 1991 with a new rotary on-off and volume control knob. Pushing this knob will also change the frequency display to the time display. The 5-band equalizer was also changed to a manually controlled system. Internally, the upper frequency range of this radio has been expanded from 1610 to 1700 kilohertz to accommodate the future expansion of the AM broadcast band. The FM frequency range remains the same as that on all Chrysler radios, 87.9 to 107.9 megahertz. Also carried over for 1991 is the RDP compact disc player. With the radio on, a logic control feature overrides the radio and cassette player when a disc is inserted. When the radios we've looked at are placed into a vehicle, they're matched with a speaker system that is custom designed and built for that vehicle. The RAL and RAS radio may be installed with 2 or 4 Chrysler full-range speakers. The locations of these speakers is dependent upon the type of vehicle. The RAF and RAB radios are also installed with 4 full-range speakers. These systems are only available on the Dodge Monaco. The premium speakers for the Dodge Monaco are the Jensen AccuSound speakers that include 2 coaxial speakers mounted in the rear package tray and 1 woofer and 1 tweeter mounted in each of the front doors. They're only installed with the RAX and RBB radios. The woofer reproduces bass frequencies and the tweeter reproduces the treble or high frequencies. A coaxial speaker is a combination of both woofer and tweeter in the same assembly. This is the Chrysler Infinity One sound system. It consists of the RAN radio with RCE Infinity speakers. The RCE speakers are a bi-amplified Infinity system in which individual speaker amplifiers in conjunction with frequency filters produce a powerful yet high-quality sound. In a bi-amplified system, the tweeters are driven by 4 amplifiers in the radio and all the woofers have individual amplifiers. As with all Chrysler sound systems, the type and location of the speakers is dependent on the vehicle. Vehicles like the Dodge Spirit, Plymouth Acclaim, and Chrysler LeBaron sedan will have 4 coaxial speakers, sometimes referred to as 8 speakers in 4 locations. On the other hand, the Dodge Daytona and Chrysler LeBaron Coupe will have 2 tweeters, 2 woofers, and 2 coaxial speakers, or 8 speakers in 6 locations. The Chrysler Infinity 2 sound system includes the newly designed RAY radio and the same RCE speakers as the Infinity One system. As with the Infinity One, the location and type of speakers will vary according to the vehicle. New for 1991 is the RCK speaker system. When added to the RAY radio, the RCK speakers create the RS sound system. The RCK speakers are the Infinity Reference Standard, or RS speakers, with a trunk-mounted 120-watt amplifier. The system includes 4 coaxial speakers and 2 woofers, or 10 speakers in 6 locations. This new sound system is available only on C and Y bodies in 1991. The RAY radio is also available with standard Chrysler full-range speakers on C and Y bodies in 1991. A chart that shows the locations and types of speakers for most Chrysler vehicles is included with this month's release. Hello, Mike. What brings you out here today?
Hi, Bud. I was wondering if I might get your opinion on a few things.
Sure. What's the problem?
Well, I've gotten a few customer complaints about radios not working properly. Now, they claim the radios seem to be giving too much noise and static, and sometimes lose the station. Now, I've checked out the radios, and there seems to be nothing wrong with them. I've even gone so far as to replace the radio, but the customer still comes back with the same complaint. Now, I think the problem is with reception and not the radio.
Well, you're probably on the right track, Mike. The problem may be because of natural radio frequency interference, or RFI, that occurs on both AM and FM. Now, you can't do anything about this natural RFI, and replacing the radio won't correct the problem. You'll have to explain this to your customer. You may also have to explain to your customer the differences and limitations between AM and FM signals.
Well, I'm not so sure I can remember what the differences are, much less try to explain them to a customer who's in a hurry.
If you have a few minutes, I can give you a brief explanation of what the differences are between AM and FM. Radio waves are a type of electromagnetic radiation that travel through space at the speed of light. A radio wave's frequency is equal to the number of waves or cycles passing a point in 1 second, and its unit of measurement is called the hertz. The height of the radio waveform is called its amplitude. In an amplitude-modulated, or AM system, the sound is broadcast on the edge or peaks and valleys of the radio wave. In a frequency-modulated, or FM system, the sound is broadcast inside the FM radio wave. During transmission, these radio waves will pick up electrical disturbances, such as engine ignition, power lines, neon signs, and thunderstorms. These disturbances mainly affect the wave amplitude and thus become a part of the AM reception. Because the sound in an FM radio wave is inside the wave, it's shielded from most interference and reaches the listener as only an insignificant click or pop. This same interference on AM radio comes through as a loud crackle or rumbling sound.
Isn't that interference also called static?
That's right.
And is it true that AM waves travel farther than FM waves?
Right again. That's because AM radio waves are low-frequency waves and tend to follow the curvature of the Earth. Generally, this allows AM broadcasts to be received at longer distances. At night, the range of an AM broadcast may increase significantly as the ionosphere reflects the AM waves back to the Earth. Because AM waves travel further at night, and because there are so many AM radio stations, you may notice that 2 stations may mix and become garbled and unintelligible. You may have experienced AM reception fading while driving.
Yes, while driving under an overpass.
My heart,
This is due to a significant decrease in signal strength caused by driving under the overpass. It also happens when driving behind tall buildings in downtown areas and when trying to receive signals from distant stations.
FM waves are a different story. They are not reflected by the ionosphere, and they do not tend to follow the curvature of the Earth.
That's why the range of FM is dependent upon the height of the transmitting antenna. This is known as line-of-sight transmission.
Since FM waves reflect off solid objects, it is often possible to receive FM broadcasts under bridges and overpasses where AM reception may fade out.
And never get low. You'd better let love depart.
However, like light waves, FM signals can be blocked by tall buildings or hilly terrain, which will interrupt the direct line transmission between the station and your vehicle, causing FM flutter. As you move out of these shadowy or dead areas of the transmission, the station will return to normal. Have you ever experienced multipath cancellation?
Is that when FM signals cancel each other out?
Right. Whenever two waves or a reflection of the same wave cross each other, cancellation can occur. This can cause intermittent reception and static if the car moves into these exact locations where the waves cross.
Something that happens to everyone while driving is losing a station to a stronger one.
That's called FM strong signal capture. And as you said, it occurs when you're tuned to a weaker station and pass near the transmitter of a stronger signal. The radio will momentarily receive the stronger station. As the radio passes through such an area, it may switch back and forth between stations.
Take me down tonight.
FM stereo signals must carry much more information than a monaural FM broadcast. So, flutter, cancellation, and capture are more noticeable when listening to FM stereo stations. But again, you can do nothing about all this RFI we've discussed. Changing the radio won't help. You'll just have to explain it to the customer. Also, everything we covered is in this Chrysler Sound System booklet, which is included with every new Chrysler vehicle.
Okay. Well, thanks a lot, Bud. I think that now I won't have any problem explaining it to the customers. Well, I'll let you get back to your work.
No problem, Mike. I was just looking over this new RS system for 1991. If you'd like, you can stick around. I'll tell you more about it.
Great.
This is the new Infinity Reference Standard, or RS system, that's available in C and Y bodies for 1991. It includes a new look RAY radio, RCK speakers, and a separate 120-watt amplifier.
Well, that's quite a system. It sounds like it may be a bit rough to diagnose.
Well, not really. As a matter of fact, included in this month's release of Mastertech are flow charts that'll help you in the diagnosis of not only this radio, but all of Chrysler's radio systems.
Can we run through a few problems that I've experienced with other radios?
Sure, why not? We can use this vehicle.
Okay.
What kind of problems have you had?
How about this? I received a complaint of no sound coming from one speaker.
That's a good one. First of all, we want to follow the 6-step troubleshooting procedures and begin by verifying the customer's complaint. Using Chart 2, we see that we must first turn the ignition to the accessory position, and then tune the radio to a known strong station. Adjust both the fader and balance to check which speaker has the problem. That's how you narrow the problem to one or more speakers on all Chrysler systems.
I worked on a Dodge Monaco, and the radio in it had a self-diagnostic mode. When you pressed the M1, Seek down, Seek up, and M5 push buttons in sequence, the radio would send audio diagnostic tones to the speakers.
Right. All Monaco radios will provide tones alternating between 200 and 6.9 kilohertz at 1-second intervals for a total of 60 seconds. Pressing any other push button, except eject and volume, will stop the test tones. This feature provides signals for a simple test for speaker system continuity. Having high and low frequencies present allows you to check woofers and tweeters in a Monaco premium sound system.
It's a pretty nice feature, and it really saves time.
Okay, so now by adjusting the fader knob, we've narrowed the problem to one front speaker. On the RS system, the speakers are driven from the amplifier located in the trunk. So we'll have to check the connectors from the amp to the speaker. On all other Chrysler systems, you would check the connectors in the rear of the radio. You'll have to check the vehicle's wiring diagram to find out where these connectors are located and their pin locations. After removing the rear trim panel in the trunk and disconnecting the amplifier connector, check for a short to ground on both leads going to the speaker. You should always get an open circuit reading when doing this test. Here we have a reading of 4 ohms on one lead and 0 on the other. Since we do not have an open circuit reading, we have narrowed the problem to the harness. If our problem was not the harness, our next step would have been to test the speaker. Here, we should receive a reading of 3 to 5 ohms. Inspecting the harness, we find that a screw has penetrated one of the wires. The harness will have to be repaired.
I ran into a shorted harness like that between the radio and speaker, and it caused the radio to fail. In fact, I replaced the radio twice before I realized that the short was in the speaker wire.
Well, that's because the short to ground in the harness increases the flow of current from the radio. This short to ground may also cause the radio to shut off immediately, or in some cases after the radio has warmed up. And this may lead you to the misconception that the fault is in the radio.
Well, this diagnosis wasn't any different than checking any other sound system. All speaker diagnosis follows the same procedures. They all have at least 2 leads to check. The only difference here is that you check the connectors from the amp instead of from the radio.
Chrysler sound systems use different types of speakers for different applications. On the Chrysler Infinity 1 and 2 systems, you'll find that the Infinity coaxial speakers have separate amplifiers mounted on the rear of the speaker like this.
Now, with the amplifier mounted in the rear like that, is it possible to connect these speakers to a non-Infinity radio?
Well, yes, you can, but the sound quality will be diminished because each system is custom designed and built for each vehicle. So don't mix systems.
What are some of the other speakers that you have here?
This is a full range speaker that'll be included in most standard speaker systems. This tweeter produces the treble or high frequencies, and that woofer produces the bass or low frequencies. Now, when tweeter and woofer are installed in a vehicle, they're installed as pairs. This coaxial speaker is a combination of both the tweeter and the woofer, but does not have a separate amp in the rear, as does the Infinity coaxial speaker.
With the sound system tailor-made for each vehicle, it's important that you replace a speaker with the same type.
That's right. And this month's Mastertech includes a chart that describes the type of speakers and their locations in Chrysler vehicles.
What if there's no audio or display at all from the radio or tape player?
Using Chart 1 in our Mastertech reference manual, we first make sure that the system is powered up and that it's tuned to a known strong AM or FM station. There is no audio and no display on the radio. Next, we check for voltage to the radio. Check your service manual to find out what fuses in the fuse block pertain to the radio. Most Chrysler radios contain at least 2 fuses. One ignition feed, normally labeled radio in the fuse block, and one for the radio memory keep alive feed. Because the vehicle we're working on has an RS system, we have one additional fuse, one for the trunk-mounted amplifier.
On an Infinity 1 and 2 sound system, I found that if the fuse for the amplifier ever opens, I would still receive sound from the tweeters.
Well, that's because it's a bi-amplified system, and there are separate fuses. You should always check your wiring diagram to be sure you've checked all the fuses. Checking the fuses, we find that they both are okay. Our next step is to check to see if the connector is connected properly. Now, to do this, we must first remove the radio from the instrument panel. Refer to the vehicle's service manual for the proper procedures for radio removal. If the connector is connected properly, remove it and check for battery voltage at the radio ignition feed and radio memory feed. Now, check for continuity between the radio chassis and the body ground with an ohmmeter. Now, in our case, the harness checks out fine, and the radio is receiving power, and it's grounded. So the problem must be in the radio, and it must be replaced.
How about intermittent or weak reception or radio noise that is not caused by RFI?
Well, that sounds like an antenna problem. To troubleshoot an antenna, you must first remove the radio to see if it's grounded securely to the chassis. Also, check to see if the antenna plug is properly connected to the radio. Antenna performance may be tested by substituting a known good antenna. It's also possible to check short or open circuits with an ohmmeter once the antenna cable is disconnected from the radio. Continuity should be present between the antenna mast and radio end pin of the antenna cable plug. Wiggle the cable over its entire length to reveal intermittent shorts or open circuits. If, when wiggling the cable, we find an open circuit, we'll have to replace the cable and continue our check. When checking an antenna, you should find no continuity or a very high resistance of several megohms between the ground shell of the connector and the radio end pin. With the antenna installed, you should also find continuity between the antenna mounting hardware and the radio ground strap.
What about problems with cassette and CD players?
If you have a problem with a CD player not working, your first step would be to check to see that all the packing screws have been removed. Next, with the radio on, we'll check for voltage at pin 4 and shielding of the CD cable. If there is ignition voltage at pin 4 and a good ground, then the problem is in the player and it must be replaced.
I've loaded discs into players and they've been ejected immediately, and the player displayed an E.
Well, that could mean that the surface of the disc is dirty or clouded by moisture. The surface of the optical parts are clouded by moisture, or the disc was inserted with the label side down. In the case of the moisture problems, keep the unit on for at least 30 minutes or until the moisture evaporates. The CD player also will display hot when its temperature exceeds 140 degrees Fahrenheit. Now, as for cassette player problems, your customers should know that cassette players are delicate mechanisms and that they should be careful about the quality of tapes they use. Don't use a cassette tape that has a loose label or deformed case. Make sure that there's no slack in the tape and that they don't use tapes longer than C90. Should a cassette tape get caught in the player, don't try to force the tape out. Trying to force the tape out will only damage the tape player mechanism and the tape. Take the player to a service center for repair. The tape will be returned. If you have to replace a radio, check to see if same-day service or next-day service is available before removing it from the vehicle. You'll be able to receive same-day service if you're within a 25-mile radius of the participating same-day or next-day service repair center and request service by 10 a.m. on a regular business day. You'll receive a radio by 4 p.m. the same day. For next-day service, you must be within the next-day delivery boundaries of United Parcel or an equivalent carrier and request a radio by 3 p.m. on a regular business day.
For proper care of CDs and cassette tapes, I can refer the customer to the CHRYSLER Sound System booklet.
That's right. That booklet has a lot of valuable information for the customer.
Well, I really have taken up a lot of your time. Thanks for all your help, Bud.
No problem, Mike, anytime. This concludes our September release of Mastertech. Remember that many of the problems you'll find in today's sound systems have simple causes like loose wires and natural radio frequency interference. In the former case, using a methodical diagnostic approach should quickly lead you to the cause. You won't be able to do anything about radio frequency interference, however, and it's part of your job to explain to the customers why these types of problems occur. We'll see you next month on Mastertech.
The emissions recall detailed in this program involves 1986 and 1987 model year Plymouth and Dodge Colt Vista two-wheel drive vehicles equipped with a 2-liter carbureted engine and Federal Emission Control System. These vehicles may emit hydrocarbons, carbon monoxide, and oxides of nitrogen in excess of Federal Emission Standards. To correct these conditions, the carburetor air bleed jets, choke shaft, and linkage must be cleaned. The jet mixture solenoid must be inspected and replaced if necessary. The oxygen sensor must be inspected and replaced if necessary. A carburetor choke adjustment shim must be installed. The enrichment solenoid jet must be replaced. The sub-EGR valve and passages must be cleaned. The EGR valve and passages must be cleaned. A vacuum hose harness must be installed, and a hose routing label must be installed. For repair of affected vehicles, emission service parts packages, part number C3940395, are being shipped free of charge to all involved dealers. In addition, you must use the fast idle release tool provided for emissions recall number 469, part number C3940272. Also, jet mixture solenoid valves, part number MD612014, and oxygen sensors, part number MD117240, are being shipped at dealer cost to all involved dealers for use as necessary. The first part of this procedure involves testing the carburetor feedback system. For visual purposes, the hood has been removed for this procedure. To test the carburetor feedback system, first remove the air cleaner and plug the vacuum hose. Next, clean the outside of the carburetor and the choke linkage with Mopar brake and carburetor parts cleaner, part number 4318037 or equivalent. Also, clean the primary air bleed jet, the secondary air bleed jet, and the choke shaft. After cleaning the carburetor, connect the positive lead of a digital volt ohm meter to one of the contacts on the oxygen sensor check terminal, and connect the negative lead to a good ground on the engine. With the ignition on, the volt ohm meter should show a positive reading. If the meter reads 0 volts, connect the positive lead of the meter to the other check terminal contact and recheck for a positive voltage reading. Next, connect a tachometer to the engine and warm the engine to normal operating temperature. Run the engine at 2,500 RPMs in neutral for 20 seconds and record the maximum oxygen sensor voltage. You should note that the oxygen sensor voltage will vary continuously. Note only the highest voltage observed. If the maximum voltage is less than 0.2 of a volt, replace the jet mixture solenoid valve. To do this, disconnect the solenoid valve connector. Remove the jet mixture solenoid valve and set it aside for return to the warranty material return center. Install a new jet mixture solenoid valve and tighten the valve to 2.2 foot-pounds or 2.9 Newton meters. Be careful not to over-tighten the valve, since this will distort the valve and cause an over-rich condition. After installing the new jet mixture solenoid valve, warm the engine to normal operating temperature and then run the engine at 2,500 RPMs for 20 seconds and recheck the maximum oxygen sensor voltage at 2,500 RPMs. If the maximum oxygen sensor voltage reading is less than 0.6 of a volt, a new oxygen sensor must be installed later in this procedure. Before proceeding on, disconnect the tachometer and volt ohm meter. The next step in this service procedure involves the installation of a carburetor choke adjustment shim. To do this, first drain about 1 gallon of engine coolant from the radiator and save it for later reuse. Next, disconnect the throttle return spring from the carburetor throttle linkage. Now remove the carburetor by following the applicable service manual procedures and drain any remaining gasoline from the carburetor in a suitable container. With the carburetor on the bench, insert the fast idle release tool between the fast idle cam lever and the wax element housing. Turn the fast idle tool counterclockwise about 45 degrees to provide a clearance between the choke adjusting screw and the plunger. Using the installation stick attached to the choke shim, install the shim on the choke adjusting screw as shown here. Now, rotate the fast idle release tool clockwise and remove it from the carburetor. Next, detach the installation stick from the shim by twisting the stick and breaking it off. Ensure that the choke adjustment shim remains securely installed between the plunger and the adjusting screw. The next part of this procedure involves replacement of the enrichment solenoid jet. To do this, locate the enrichment solenoid valve on the carburetor directly above the accelerator pump housing and remove the valve from the carburetor. Now replace the enrichment solenoid jet with a new jet from the emissions parts package. After replacing the jet, reinstall the enrichment solenoid valve and tighten it to 2.2 foot-pounds or 2.9 Newton meters. Again, do not over-tighten the valve since this will distort the valve and cause an over-rich condition. The next part of this procedure involves cleaning the sub-EGR valve. To do this, locate the sub-EGR valve on the carburetor under the accelerator pump housing and disassemble the valve by first removing the E-clip from the pin connecting the plunger to the throttle linkage. Discard the E-clip, remove the pin, and separate the throttle linkage from the plunger, being careful not to lose the small steel ball and spring located in the end of the plunger. Next, carefully remove the steel ball and spring from the end of the plunger and set them aside for later reassembly. Now, remove the plunger from the carburetor throttle body by inserting an Allen wrench through the plunger pinholes and gently twisting the plunger out. After removing the plunger, clean it with a piece of fine, wet emery cloth by twisting the plunger in the emery cloth. Do not use a wire brush to clean the plunger. Scratches from a wire brush will cause carbon to build up more quickly on the plunger. Next, clean the plunger bore with Mopar brake and carburetor parts cleaner or equivalent. A small screwdriver can be used to loosen carbon deposits in the passages in the underside of the carburetor. However, do not use any type of sharp implement in the plunger bore. Scratches in the bore will cause carbon to build up more quickly. After cleaning, thoroughly dry the plunger and bore and reassemble the sub-EGR valve in the reverse order of the disassembly. During reassembly, use the new supplied E-clip from the parts package. If required, a small steel ball has also been included in the parts package. After reassembly, check the sub-EGR valve for smooth operation. If the operation is not smooth, check and clean the throttle and choke linkages as necessary. The next part of this procedure involves cleaning the EGR valve and passages. To do this, first remove the EGR valve from the intake manifold and place a shop towel over the intake manifold carburetor openings. Next, remove any carbon deposits from the EGR valve and the intake manifold passages. After removing carbon from the valve and passages, use a new EGR gasket from the emission service parts package and reinstall the EGR valve. Next, install a new carburetor gasket from the parts package and reinstall the carburetor following the applicable service manual procedures. Be sure to reinstall the throttle return spring. After reinstalling the carburetor, refill the radiator with the original coolant. At this point in the procedure, the exhaust manifold should be sufficiently cooled down to allow the installation of the oxygen sensor. To do this, disconnect the oxygen sensor electrical connector, remove the air injection tube, and remove the heat shield from the exhaust manifold. Remove the original oxygen sensor from the manifold and set it aside for return to the Warranty Material Return Center. Then install a new oxygen sensor, part number MD117240, to the manifold. Next, reinstall the heat shield, air injection tube, and reconnect the oxygen sensor electrical connector. The final part of this service procedure involves the installation of a vacuum hose harness. For visual clarity, the distributor and some carburetor connections have been removed to better illustrate this part of the procedure. To install the harness, first assemble the vacuum control valve from the parts package to the supplied vacuum hose harness. Match the blue, red, and white tracer hoses to the corresponding ports on the valve. Next, remove the vacuum hose between the thermo valve and EGR valve as shown here. Now connect the hose assembly from the vacuum harness to the ports on the EGR valve and the thermo valve. Connect the hose from the vacuum delay valve to the EGR valve. And connect the hose from the connector to the thermo valve. Locate the vacuum line from the intake manifold, which was plugged earlier in this procedure, and cut the line as shown here. Insert the harness vacuum tee at the end of the white tracer hose into the cut ends of the line. Next, locate the vacuum hose between the carburetor base and depression chamber and cut the hose as shown here. Route the harness vacuum line with the green tracer and F connector around the carburetor and connect the cut ends of the hose to the F connector. Retain the harness in place using the shorter of the two supplied tie straps. Next, locate the vacuum line connecting the secondary air control solenoid and the secondary air control valve, and remove the line. Disconnect the remaining vacuum hose from the secondary air control solenoid front port. Connect the front hose to the T in the red tracer line on the harness. Then, connect the short line from the other side of the T to the front solenoid port. Connect the green tracer hose from the harness to the rear solenoid port. And connect the remaining green tracer hose of the harness to the secondary air control valve. Retain the hose in place using the longer of the two supplied tie straps from the parts package as shown here. Next, install the supplied bracket on the secondary air hose near the air cleaner assembly and clip the vacuum control valve into the bracket. Now reinstall the air cleaner assembly. Finally, locate the hose routing label on the underside of the hood and thoroughly clean the label. Select the appropriate label from the emissions parts package and install the new label over the old hose routing label. Use label number MD170044 for vehicles equipped with manual transmissions, or label number MD170045 for vehicles with automatic transmissions. Dealers are urged to give their full support to this important program by serving all involved owners promptly and courteously. Dealers should also be aware that the EPA will be performing an audit of this recall. Failure to perform every step of this procedure as instructed could subject affected dealers to significant fines. For further information regarding this service procedure, vehicle lists, repair parts, and claim reporting procedures, refer to the Dealer Emissions Recall Notification Letter, number 478.